In this exercise, you're given a map, f of x, and you're asked to verify that the fixed points of that map are 0 and 3. So that's going to be easy, but the fun part of this exercise is using that information to help you figure out what the period 2 points are of that same map. So pause the video and see if you can indeed make use of that information to simplify your task. The easy part is finding the fixed points of the map itself. So for that, we're looking at the equation f of x is equal to x. In our case, f of x is 2x squared minus 5x, and that should be equal to x, or 2x squared should be equal to 6x, or x squared should be equal to 3x. And indeed, the solutions there are, as was given in the exercise, 0 and 3. Okay, that's the straightforward part. Now moving on to trying and find the period 2 orbits. So for that, we need to solve the equation f applied twice to x, giving us x. Now f applied twice to x is indeed f of x, and that thing should be equal to x. So basically, in order to write the left-hand side here, we should start from our original equation f of x, but every time we see an x, we replace that x by f of x. So in this equation, we replace x by 2x squared minus 5x. So this becomes then 2x squared, but replacing x by f of x, 2x squared minus 5x squared minus 5, and then we have x, 2x squared minus 5x. And that's going to be 2 times, and then we have here 4x to the power of 4 minus 20x to the power of 3 plus 25x squared. Okay. And then minus 10x squared plus 25x. And since we're looking for fixed points, that should be equal to x. So here's an equation that we need to solve. Let's first clean things up a little bit more. So this brings us to 8x to the power of 4 minus 40x to the power of 3. And then we have 50 minus 10, which is roughly 40x squared. And then finally we have 25 minus 1, that's 24. So this thing should be equal to 0. It's quite obvious that 0 is indeed a solution, so we can factor out an x here. Let's also, since all of these coefficients are even, let's divide everything by 2. So we have 4x to the power of 4 minus 20x to the power of 3 minus 20x, and then plus 12. And here I messed up because I didn't bring out the x. So we have 4x cubed, 20x squared, 20x plus 12. And this thing should be equal to 0. So here we have a scary cubic polynomial, and we have to find the zeros of that polynomial. So that's a bit of a difficult task. But again, remember, the fun part of this exercise is making use of the fact that these guys are fixed points to help us simplify the solution to that equation. So perhaps at this point, you can pause the video again and think about what you would do to make your life easier. So if we know the fixed points of the map itself, if we know that f of p is equal to p, then obviously if we apply the map another time, it will also be the case that f2 of p is equal to p. So that will tell us that the fixed points of the map, the original map, will also be solutions to that equation that we're trying to solve up there. So the solutions 0 and 3, the fixed points of the original map, should also result in a 0 to that equation over here. For 0, that's indeed pretty obvious because that's indeed a factor x that we have there. But this knowledge now tells us that this polynomial up here should be divisible by the polynomial x minus 3. And if we do that, we end up with a quadratic equation, which is much more pleasant to find the roots of. So what we're going to do is some good old-fashioned polynomial long division to factor out x minus 3 of our original polynomial here, which is 4x cubed minus 20x squared. That should be a plus, okay. Plus 20x and then plus 12. Good, let's divide that by x minus 3. Okay, 4x cubed divided by x, that's going to give us 4x squared. So we have 4x cubed minus 20x squared. And if we then subtract those, that's going to give us minus 8x squared. Minus 8x squared divided by x, giving us minus 8x. Minus 8x, okay, minus 8x squared, and then plus 24x. So if we subtract those, it's going to give us minus 4x. So finally we have minus 4 over there. So minus 4x plus 12. Subtracting those, hooray, gives us indeed 0, as we expect this thing is divisible by x minus 3. So now we've reduced the problem of finding the zeros of that cubic polynomial over here to the much more pleasant problem of finding the zeros of that quadratic equation over there. And actually we can divide everything by 4 rather, to give us the equation x squared minus 2x minus 1 is equal to 0. So if we find the x's that satisfy this equation, we will have found the period 2 points of our orbit. Luckily, that's quite easy. You can also use the simplified formulas in case the coefficient here b is even. So we have minus half of the coefficient of b, plus or minus, and then the square root of that same half coefficient of b squared, minus the product of these two coefficients. That's going to give us minus 1. And that is actually 1 plus or minus the square root of 2. And these will be the fixed points, the period 2 points of our map.